Okay, we now have 30 in the meeting. So everyone, please join. Use QR code or use URL classpoint.app53139. Okay, we will do activity today using ClassPoint. So before we start with trust example, internally indeterminate trust. This morning we actually discussed on externally indeterminate, and tonight we will discuss externally, not externally, internally. Okay, this morning externally, tonight internally. Okay, we have two types: externally indeterminate trust and internally indeterminate trust. So we will discuss internally indeterminate trust for this session. Okay, but before that, I want you to answer. I think there are about 7 questions. Okay, this is just I just want to see your understanding. If you join my class, if you watch my recording in YouTube, I believe you can answer. Okay, so please get involved because this is evidence that I need to submit to you future. Okay, this activity, okay, I need you to get involved. Okay, please, now we have 36 in the meeting room. So now 33 has joined. Okay, please, all of you join using QR code or using URL classpoint.app53139. Okay? Okay, the first question. The first question is, why do we need to study indeterminate structure? Okay, this is word cloud. You just write your answer in your opinion. Why do we need to study indeterminate structure? Wait, I need to stop sharing and reshare again. Okay. For those who just joined this meeting room, please use QR code given in the WhatsApp. Okay, use QR code I have given in WhatsApp group, yeah. Okay, this is the first question. Why do we need to study indeterminate structure? Okay, so I believe if you watch the video, all my video, and you attend my class, you should be able to write something regarding this question. Why do we need to study indeterminate structure? Okay, so we start right now. Okay, we got one answer: to identify the unknown forces in the structure. Okay, calculate reaction. Any more? We have about 37 in the class. To ensure the structure is stable, find the forces in structure. The indeterminate structure have less bending moment. Okay, any more answer? To find all the unknown reaction in structures. To calculate redundant. Find the forces in structure. because we need to calculate the reaction. The indeterminate structure have less bending moment. To identify the unknown forces in the structure. Okay, many give the answer, give calculate reaction as the answer, find reaction to ensure that the structure is stable. Because we cannot solve indeterminate structure. We need to design and study about structure. Any more answer? Okay, we will stop at 2 minutes. To get redundant value, okay, 2 minutes. I will close right now. Okay, so basically all answer is correct. Okay, we use flexibility method in order to analyze unknown reaction where we cannot calculate unknown reaction using equilibrium equation only. To get redundant value, find the forces in structure, correct? So all give quite similar answer. And actually we need to study indeterminate structures because actually in real all structures that we have are indeterminate structure. And indeterminate structure in terms of stability, in terms of strength, okay, in terms of displacement is smaller than in indeterminate structure. The displacement in indeterminate structure is smaller than determinate structure, because when we put when we have more support, so actually we increase the strength. Okay, so I accept all the answer. And beside that, okay, please take note what I have explained previously, okay, about the strength, about the stability, about the displacement, why we have to calculate or to analyze indeterminate structure. Okay, next question. Okay, so this one you will write, okay, the answer. How do you calculate redundant in indeterminate frame? Okay, write your answer based on your understanding. How do you calculate redundant in indeterminate frame? Okay? Okay, we start now. Okay, don't be shy, don't worry. You can write whatever that you think is the answer. Okay, 6 respondent. Okay, we have 43 now in the class. Okay, using DOI, using compatibility equation, applying superposition and compatibility equation. Compatibility equation, many choose compatibility equation as the answer. Find reaction in primary and redundant. Use cutting section M0 and M1. Using flexibility method, DOI is a reaction -3. Using the compatibility equation, degree of indeterminacy. Okay, Okay, DOI is unknown reaction minus equilibrium equation. Okay, 31. Any other answer? Apply a unit load at the redundant and use flexibility method. Okay, so I will stop at 3 minutes. So please everyone get involved. So because I can actually get analysis of this response in Excel form. So the participation is very important. Okay. So 3 minutes. So for those who has not yet give respond, okay, please answer the next question. Okay, save this one first. Okay, how do you calculate redundant in indeterminate frame? Okay, so based on the answer you gave just now, I think everyone understand what is actually the flexibility method. Okay, so next question. Okay, this is a quiz, yeah, a quiz. So not counted of course. So this is just to rank you, okay, to see your understanding based on the given. You just need to choose the correct one. Okay, some question may have more than one correct answer. Some question, not all. Okay, when we cannot calculate unknown reaction using equilibrium equation, when we cannot calculate unknown reactions using equilibrium equation only, we will use one method that is called as, A, unit load method, B, flexibility method, C, force method. Okay, do it quickly. Okay, 49 in the class point. Okay, I need 49 to answer. Where are the rest?
I'm done.
Yeah. Okay, I will close cepat. I will close at 2 minutes.
Wait. Sekejap, Doktor.
Cepat. You have another 15 minutes. 39. Where else? Okay. Okay. Refer back to the question. Refer back to the question. When we cannot calculate unknown reaction using equilibrium equation only, we will use one method that is called as A. Unit load method, B. Flexibility method, C. Force method. Okay. Okay. What is the answer? Okay. So flexibility method is also called as force method. So there are two answers in this question. There are two answers. So we have 35, 90% choose B. But please remember, please take note that force method is also flexibility method. Okay, I mentioned previously in the textbook, Hibbeler textbook, flexibility method in the textbook is called as force method, not flexibility method. So both flexibility method and force method are the same. Okay? Okay, we move to next question. Okay, now 54. So please, all in the class point, please respond. Yeah? Okay, redundant will be determined. Redundant will be determined by solving. Redundant will be determined by solving what equation? Which is derived by principle of superposition. A. Flexibility equation. B. Compatibility equation. Okay, again, redundant will be determined by solving blank equation, which is derived by principle of superposition. A. Flexibility. B. Compatibility. Okay, choose the right answer. Okay, 2 minutes from now. 2 minutes. Okay, another 40 minutes. 40 seconds, sorry, 40 seconds. Okay, we have 55 in the class. 44 has responded. Okay, we have another 10 seconds. Okay. submission. Okay? There are two answers correct. There are two answers correct. Okay? For the question, redundant will be determined by solving flexibility equation. Flexibility equation is also same with compatibility equation. That is what we call as flexibility method. Okay? Not only compatibility equation, compatibility equation is also known as flexibility equation. Okay, so we move to next question. Okay, the indeterminate beam after removing redundant while external loading are remain is called as the indeterminate beam after removing redundant while external loadings are remain is called as A. Primary beam, B. Redundant beam, C. Actual beam. Okay, choose the correct answer. Choose the correct answer. Okay, 2 minutes. Okay, thank you. We have 57 right now. Indeterminate beam after removing redundant while external loading are remain is called as okay, we have another 55 seconds. Okay, where are the rest? Okay, 46. Okay, we have another 15 seconds. Okay. Okay, the answer is A. The answer is A. It is called as primary beam. Okay? When we remove redundant and we remain all external loading, it is called as primary beam. Okay? So move to next question. If we have, okay. Okay. In indeterminate beam, where A is fixed and B is roller. Okay? In indeterminate beam, where A is fixed and beam is roller, FBB refers to A. Rotation due to a unit value of By or deflection due to a unit value of By. So where is the right answer? Okay, what is the right answer? In indeterminate beam, where A is fixed and B is roller, FBB refers to rotation. A is rotation due to a unit value of By, or B, deflection due to a unit value of By. Okay, 2 minutes from now. Okay, read the question carefully. Okay, 30. Okay. 39. 40. In indeterminate beam where A is fixed and B is roller, FBB refers to A, rotation due to a unit value of By, B, deflection due to a unit value of By. So choose the correct answer. Okay, another 30 seconds. Okay, the answer is deflection, not rotation. Okay, the answer is deflection, not rotation, because By is force, is equal to P. P delta, P delta M theta. Always remember, the partner of P is delta, P delta. And M, moment, is theta. Theta is rotation. Delta is deflection. So moment, if moment at A is the redundant, then only we determine rotation. Okay. Now, By is P. By is P, so it is deflection, not rotation. Okay. By induced deflection. By induced deflection at B, not rotation. Okay, and there is no rotation at B because B is roller. Okay, and rotation, we can calculate if we want using unit load method. But the answer for this one, because By is the redundant, so the partner is deflection. P and delta. P and delta. Okay, it is deflection due to a unit value. Deflection due to a unit value of By. Okay, so next, okay, we will see if we have another question. Okay, last question. Okay, read the question carefully. The three remaining reactions can only be calculated by using equilibrium equation. The three remaining reaction can only be calculated by using equilibrium equation. Choose yes or no. Yes or no. Okay, read the question carefully. The three remaining reactions can only be calculated by using equilibrium equation only. This is the last step of analysis. When we analyze beam, analyze frame, analyze truss. Truss, of course, we have to continue to calculate member forces, but in beam and frame, this will be the last step. After getting redundant, we will continue to calculate remaining reaction. Okay, the remaining reaction can only be calculated by using equilibrium equation only. Okay, yes or no? Yes or no? Okay, we have another 30 seconds. Okay, 45 has responding. Okay, the three remaining reactions can only be calculated by using equilibrium equation. Yes or no? Who choose yes and who choose no? Okay, another 5 seconds. Okay. Okay, the answer is B. Okay, why the answer is B? Can anyone tell the class why the answer is B, not A? Why the answer is B, not A? Look at the question again. The three remaining reactions can only be calculated by using equilibrium equation. Yes or no? The answer is no. The answer is no. Why? Why the answer is no? Can anybody tell me why the answer is no, not yes?
We can use superposition equation to calculate remaining reaction.
Yes, correct. Okay, we can actually calculate remaining reaction using either equilibrium equation and superposition method. So we have two options. And by using superposition method or principle of superposition, it is actually easier than using equilibrium equation. Okay, so thank you for your response. So kita tengok siapa yang menang malam ni. Okay, this one. Apa tu yang menang? Okay, number one, Daniel. Okay, 80% correct. Okay, no one got 100%. Okay, tak apa, next time cuba lagi. Okay, number two, Syahir Hafizi. Number three, Izwan. Number four, Hakimi. Number five, KD. Number six, Mirza. Okay, thank you very much. Okay, for those who have involved into this activity. Kita tengok. Okay. Okay, thank you. So close this. So next time I will set again activity. So in order to know your understanding, and you also can know your understanding level. Okay, so thank you very much. Yang menang tadi siapa? Yang top 1, top 3 tu? Top 3 tu nanti lepas midterm datang jumpa saya bagi present. Okay? 3 yang tadi tu. 3 yang first. The first 3. Okay, now we will continue back to OneNote. Okay, so this is what we are going to discuss tonight. Okay, this morning I actually discuss this one. Please watch the recording I have uploaded in YouTube. Okay, in YouTube, this one. Okay, this one. Okay, the difference between this truss. Okay, this truss and this. Okay, is due to externally and internally condition. Okay, so this morning I have discussed about externally indeterminate truss. Externally indeterminate truss, where redundant is come from reaction. When redundant, because reaction, we calculate reaction whenever the structure is loaded. The structure is loaded by external loading. Reaction, we calculate reaction because we calculate based on external loading. So when there are loadings, maybe point load, maybe UDL, triangular load, and so on, all loadings. Okay, when we have in the structures, when we have reaction, means that we calculate based on external loading. That is why when reaction is the redundant, it is called as externally indeterminate. Okay, externally indeterminate. You have to understand both, because in some question there are combination of externally and internally. Okay, so this time we actually analyzing this truss where it is internally indeterminate. Internally indeterminate. Look at the diagram. Okay, wait. Okay, the formula to calculate DOI for truss. Okay, because we need to include member force when we calculate redundant, when we calculate degree of indeterminacy. Okay, we have to use M plus R. We have to use M plus R minus 2J. M plus R minus 2J. And we need to check as well with R minus 3. Okay, so we need to check with these two formula. Okay, degree of indeterminacy. M is for member, R reaction, J is joint. It is M plus R minus 2J for degree of indeterminacy. Okay, and we have to check also R minus 3. R minus 3 ni we use to identify whether the truss is internally or externally. If R minus 3 is equal to 0, that means that the truss is internally. If we get R minus 3 equivalent to 1, and yang atas ni, if it is equivalent to 1, yang bawah if it is equivalent to 1, means that this is externally indeterminate. Because when we calculate based on based on total unknown reaction minus 3, it is actually redundant come from reaction. Okay, but if when we calculate, we get R minus 3 is equal to 0, and we calculate redundant, we calculate DOI M plus R minus 2J, we get 1. It means that the truss is internally indeterminate. Internally indeterminate. Internally indeterminate means member force is the redundant, not reaction. Member force is redundant, not reaction. Okay, so we will calculate this. M plus R minus 2J, M plus R minus 2J, and R minus 3. Okay. Okay, let's start. So DOI is equal to M. How many M members? 1. Okay, wait. Okay. DOI, degree of indeterminacy, M. How many M? 1, 2, 3, 1, 2, 3,
8.
4, 5, 6, 7, 8. 8,
8.
8, eh? Okay, it is 8. 8 member. Reaction, how many reaction?
3.
3 reaction. Minus 2J. How many join? How many join?
5.
5. So it is equivalent to? It is equivalent to? Equivalent to?
1.
1.
1.
1. Okay, means
1.
that there is 1 redundant. There is 1 redundant. Redundant. Now we want to check. We want to check there is 1 redundant in the truss. In the truss. Okay, now we want to check whether the redundant is member force or reaction as the redundant. Okay, how to check? How to check? Okay, it is R minus 3. R minus 3. It is R minus 3 equal to how many R? How many R? 3, right? Reaction is 3. 3 minus 3, we get 0. 3 minus 3, we get 0. 3 minus 3, we get 0. It means that, okay, we have to choose member force as redundant. So externally, dia dah stable. Okay, externally dah stable because R minus 3 is equal to 0. If R minus 3 is equal to 1, means 1 that we get from the above formula is actually refers to the redundant. Redundant come from reaction. Now, when R minus 3 is equal to 0, but still we have 1 for redundant, it means that redundant is come from member force. Member force, not reaction. So, yang ni means that, okay, we can conclude that the structure, the truss is externally stable. Okay, externally stable. Okay, the truss is externally stable. Okay, but and the redundant is come from member force. Member force means that we have to, it means that we need to remove one member force. One member force. Let's say we will use BD. We will choose FBD. Okay, normally when we have member force as redundant, we normally remove yang kat tengah-tengah tu. Either we remove BD or we remove EC, CE. Either one can be removed. Okay, either one can be removed. So let's say we choose BD. We choose to remove member BD. So the redundant is FBD. The redundant is FBD. The redundant is FBD. So it is FBD. This is the redundant. Okay, this is the redundant. Okay, until this, do you have any question? Do you have any question until this?
Tak ada, Doktor.
Clear? Okay. Okay, now, once we have chosen the redundant, okay, straight away we can write the standard form of compatibility equation. Okay, the standard form of compatibility equation for one redundant. The standard form of compatibility equation for one redundant. So as usual, same as beam, same as frame. So it is, remember F is force. So it is P. P delta. P delta. Okay, P delta. Okay, equal to actual. Actual is equal to 0 except when there is a support settlement. Okay, except when we have support settlement. Okay, we use standard form. It is F, it is, sorry, not F, it is delta. It is delta. Okay, delta. F is for redundant. This is for primary. Okay, delta 1 not. Delta 1 not. Okay, F, small f, for flexibility coefficient. This is F11. F11 times F. Just now we choose BD. BD. Okay, this is BD. Okay, so this is, okay, the compatibility equation. There are two displacements that we are going to determine, delta 1 and F11. So this is also the reason why we use the numbering instead of using ABC. Because when redundant is member force like this, we will find that the label is BD, not B, not A, like when redundant is reaction, because it occur at position A, it occur at position B. Okay, and actually there is an example in the textbook, writing the equation like this. Kalau you jumpa, dia tulis equation tu macam ni. Okay, 1 is for BD. Dia tulis sini BD. BD macam ni. So 1 become BD. BD dot BD kali dengan FBD. So which one is the easiest? By using numbering or by using BD as the symbol for redundant system?
Numbering.
Okay, so you can find the example in textbook. Okay, written like this. Okay, anyway, we choose the The first one by using numbering, okay, so that we have the standard form, delta 1 node plus F11 times redundant. This is R1, this is R1, and we put the R1 as FBD directly. Okay, so inside this we have two displacement which is come from two system called primary truss and redundant truss. Okay, delta 1 node is displacement in primary truss and F11 is displacement in redundant truss. Okay, and the formula to calculate delta 1 node and F11, okay, because the member force, the internal forces in truss is member force, not bending moment. Okay, in beam and frame we integrate moment equation because bending moment is internal forces in beam, in frame. But now we analyze truss, and in truss internal forces in truss is member force or axial force in the member. So that is why we need to use different formula to calculate deflection. So it is delta 1 node, which is equal to, okay, and in truss analysis, we don't use EI, but we use EA. We don't use EI, but we use EA. Okay, in truss. Okay, bending EI. Okay, bending EI we use in beam and frame only. Bending. Okay, this is axial. EA is axial rigidity. Bending is flexural rigidity. EI is flexural rigidity. Okay, EA axial rigidity, okay, occur in truss only. Okay, so take or refer to the formula in unit load method. Under unit load method analysis of truss, the formula to calculate deflection in truss, okay, we use N for member force, so there will be 2N, N times L. Okay, we need to put summation. Okay, it is N. Okay, the basic formula N times L over AE. So we have to adapt and adopt into flexibility method. Okay, we have 2N, so it will be N1 N naught, N1 N naught L, N1 N naught L, N1 N naught L. Okay, this is N1. Okay, we use the notation N1. Okay, second one is N naught L over AE. So this is the formula to calculate delta 1 naught. Okay, so we have the second formula, which is F11, which is the deflection in redundant system due to a unit value of FBD. Due to a unit value of FBD, okay, F. Okay, it is F11, so it is N1 square. N1. So it is N1 square. N1 square. This is N1 square. Okay, so from this, there are two N, N1 and N naught, N1 and N naught. So what is N1 and N naught? So, okay, so start with N1. N1 is So N1. N naught first. N naught. N naught is member forces. Member forces in primary truss. Okay, in primary truss, and N naught is N1, sorry, N1. N naught and N1. So N1 is member forces. N1 is member forces in redundant truss. Redundant truss. So we have two. We have two, N naught and N1. So we know that we have two systems. We have two systems. One is called as primary truss. Primary truss is a determinate truss after we remove FBD. Okay, after removing FBD. And redundant truss is the same truss, the same type of primary truss. Okay, with the same support. Okay, the same support. But we need to remove all external loading, and we have to apply a unit value of FBD. A unit value of FBD, okay, in the truss. It is called as redundant truss because in actual condition, in actual truss, there is member force FBD or NBD. Okay, but we have removed that one from the primary truss, and for redundant truss we have to apply back a unit value, but we have to remove all the unknown external forces. Okay, these two condition is just like we analyze real system and virtual system. Real system and virtual system, same condition. Primary truss is determinate truss subjected to all external loading, and redundant truss is determinate truss subjected to a unit value of FBD. Okay, so we have to analyze two truss. Okay, we get back to this. Okay, we get back to this. So we have to draw the truss. Okay, we have to draw the truss. Okay. Okay, when you analyze truss, make sure that you draw the bigger truss because we will calculate the member forces. Okay, after this, using easy method. You don't need to calculate one by one using method of join because what most important is the value of member forces, not how you calculate member forces. Always remember, you need to understand the learning outcome. You have learned how to calculate the member forces using method of join in CS424. And at that time, the learning outcome for trust topic, at that time, the learning outcome is like this. Students should be able to determine or to calculate reaction in determinate truss. Number 2, students should be able to calculate member forces using method of join, using method of section. Okay, time tu memang you kena tunjukkan macam mana you calculate using method of join. But this time, flexibility method is application. Okay, application. So we want the member forces because we want to calculate deflection. And there are two member forces. There are member forces inside the formula. That is why we need to have the N value. Okay, So you don't need to show using method of join. Use easy method. Okay, we remove BD. That's why I don't put the BD line here. So this one is 12. Okay, 3 meter. So all 3 meter. All 3 meter. Okay, we have pin. We have pin here. Pin and roller. Okay, we have pin and roller. So I want to copy this first. Okay. And we should have 2. We should have 2. Okay, because we have to have 2 system. One is primary, one is redundant. Okay, so the above one is the primary truss. Okay, and the lower is the redundant, primary and redundant. So in primary, I have to remove external loading 12 kilonewton. Okay, I have to remove external loading 12 kilonewton. Okay, so label, I forget to put the label A, B, C, D, E. A, B, C, D, E. So this is primary truss. This is primary truss. This is A. A. Dia dah start pening. Okay, kejap . Okay, wait for a while. So we have 2 truss. We have 2 truss. One is primary truss and one is redundant truss. One is primary truss, one is redundant truss. Remain support. Okay, remain support. Pin and roller. Pin and roller. So now after removing BD, it is determinate truss. It is determinate truss. Okay. Okay. Now, okay. So this is A, B, C, D, E. So this is determinate truss. Determinate truss due to 12 kilonewton. Due to 12 kilonewton, please calculate A, Y, C, Y. A, Y, C, Y. A, X, we already know that it is negative. This one is 12. Okay, please calculate AY and CY. Okay, AY and CY. Okay, please calculate AY and CY. What do you get? Okay, what do you get? So this is 12. Okay, 12. So due to 12 at D, okay, what is AY and CY? Okay, this is 12. So we have, okay, what is AY and CY? Please calculate quickly. Apa nilai dia? Cepat Habib calculate AY and CY. Cepat-cepat. Kita nak habiskan awal. Saya nak pergi, saya nak naik ATS esok ni pukul 6. Cepat-cepat.
Saya dapat 6, Doktor.
6. AY 6 tu dekat mana? A ke C?
C.
So CY is positive 6. Like this. Like this.
Betul-betul.
So yang ni is negative 6. Okay, 6 and negative 6. 6 and negative 6. Okay, now we will calculate using easy method. Okay, it is actually method of join but we do it virtually. Because easy method ni tak ada dalam buku teks lah. Kita akan jumpa the term easy method. It is actually virtual, it is actually join method but we do it virtually. Okay, the aim is to analyze member forces. Member forces. Okay, so yang ni memang tak ada tips. Memang you have to do regular exercise to understand about what we are going to do. Okay, in order to determine the member forces using easy method. Okay, but there is one thing that we apply, we take from method of join, where we have to check the join. We have to make sure that the join the join is in equilibrium. The join is in equilibrium in X and in Y. Okay, we have to check at each joint, at A, at B, C, and D. We have to check total Fx and total Fy, and it must be equal to 0. So we have to have this Fx equal to 0 and Fy is equal to 0 for each A, B, C, D, and E. Okay, and we can choose any joint to start and make sure that the joint that we chose to start must have one unknown. One unknown. Boleh pilih mana-mana joint pun, tak kisah. Kalau you nampak dekat D, dekat joint D ada one unknown yang you boleh solve. So start at D. If you find that dekat B pun ada one unknown. So B pun you boleh start. Dekat A ada one unknown. Dekat A ada one unknown in Y, two unknown in X. So boleh solve dekat A dulu. Tapi solve dulu yang Y unknown. As long as unknown tu mesti ada satu, then you boleh start. Dekat C ada banyak elemen. Kat situ ada banyak member. So kat situ ada dua unknown. Ada dua unknown. Okay, ada dua unknown. Dekat E pun ada more than one unknown. Okay, so C dengan E tu buat yang last kali. So you can start at A, you can also start at B, you can also start at D. And then dia boleh lompat-lompat join. You nak buat D dulu, lepas tu pergi buat A, lepas tu pergi buat B, boleh. Okay, so tujuan kita nak balance, means that kalau ada kalau 6 ke bawah mesti ada 6 ke atas. Balance. Negative 6 mesti balance dengan positive 6. Okay. 12 to the right direction mesti balance dengan 12 to the left direction. Mesti balance. Kenapa nak balance? Sebab kita kena fulfill yang ni which we take from method of join. Okay. From method of join. Okay. So kita tengok dulu dekat A. Because at A ni dia selalu ada one unknown. Okay. Selalu ada one unknown. Even though kita ada kita ada incline member. Because incline member ni bila kita resolve. Bila kita resolve kan kita dapat 2. Okay. Bila kita resolve kita dapat 2. Macam ni. Kan? Okay. If we use method of join. Kalau kita start dekat A tu. If we use method of join. Kita akan buat macam ni dekat A. So ini 6. Ini 12. Yang ni F, A, A, B, C, D, E. E. And then sini F, A, B. Ini adalah method of join. Yang mana you have to show one by one join. Ini yang saya kata tadi, tak perlu pun buat satu-satu macam ni. Because it will take much time, more time to solve. Okay. Tapi this is the basic. This is the basic. And FAE ni kita kena resolve pula in X and Y. Bila kita resolve this in X and Y, that is why tadi saya kata X ada 2 unknown. X ni ada 2 unknown. Y ada 1 unknown. Y ada 1 unknown. That is why kalau dia N triangular, tengok balik, dia mesti ada salah satu ni yang ada 1 unknown. Okay, 1 unknown. So 1 unknown is in Y. So we can solve Y first. And tengok pada 6 tu, 6 reaction at A tu, 6, negative 6. So mesti balance dengan positif. Okay, mesti balance dengan satu atas satu bawah. So ini pun 6. Okay, positive 6 and negative 6. Positive 6 and negative 6. Total is 0. Total is 0. Okay, so bila dia incline member, kita kena completekan X and Y. Because kita kena completekan vector. Remember vector? Okay, vector kan kita kena resolve in X and Y. Resolve in X and Y and kita dapat yang ni. Okay. Kita dapatlah FAE tu ataupun N AE tu kan member force. Okay. So when we get 6, okay, this 6 from when we get this 6 from this, okay, we have to calculate yang ni dulu. Okay, Y ada X ada 2 unknown. X ada 2 unknown. Yang ni satu, yang ni satu. And we cannot simply put this as 12. Cannot. This is not 12. Because combination of 2x, x1 and x2 will equal to 12. Means that combination. Ada 3 kat sini. 1, we have 1, we have 2, we have 3. So total this, we will get 0. Okay, so you jangan tengok 12 dekat ujung tu, dekat A tu, you pergi letak AB 12. Not yet, because kita kena calculate dulu nilai X pada incline member. Because 6 and X, for vector tu dia akan depend on trigonometry. So if now the X value, the trigonometry dekat sini senang sebab 3 ni. Ni 3, ni pun 3. 3 and 3. So, what is the value? What is the X value? Kat sini. So, nilai kat sini apa? Apa nilai kat situ? This is the first step. This is the first step. This is the second step. This is the third step. Apa nilai dekat number 2? We use trigonometry. 3 and 3, the ratio. Okay, now we want to calculate. We want to calculate value at 2 based on 6. So what is the value? Using trigonometry. If 3 is equivalent to 6. 3 is equivalent to 6. 3 lagi equivalent to? Apa nilai dekat nombor 2 tu? Apa nilai dekat nombor 2 tu? Cepat. Apa nilai dekat nombor 2? Janganlah lama sangat. Apa nilai dekat nombor 2 tu? Cepat. Kita nak stop at 11:30. Dah cepatlah. What is the answer? You have two triangular.
63.43.
You ada dua, dia kan vector kan dia based on trigonometry. Vector kan dia based on trigonometry. Kalau yang segitiga, the first triangular is 3 and 3, the second triangular is 6. So yang ni berapa?
6.
Pakai ratio je. This is 6. Sebab dia 3 dengan 3. Kalau 3 dengan 4, sini berapa?
7.
8.
8. Kalau 3 dengan 5, sini berapa?
10.
10.
10.
Okay,
10.
trigonometry vector ni dia based on trigonometry. That's why you kena tengok dia punya length AB tu dengan dia punya height. Okay? So this is 6. This is 6. And you have to find the hypotenuse. You have to find the hypotenuse so that you will know the member force for AE, the hypotenuse. For 6 and 6, the hypotenuse, what is the answer? 6 square plus 6 square square root, hypotenuse. So what is the value?
8.49.
At 8.49. It is 8.49. 8.49. Okay. Okay, now. Tadi number 1 kita dapat 6. Number 2 kita dapat 6. Number 3, what is the answer? Number 3. Total fx is equal to 0. Total fx is equal to 0. Now we are doing A, join A. You nak check, then you check macam ni. Okay, this is join A. Join A. We have 6 and 6. Ini join A. And we have 12. We have 12 and 6, right? 6 right direction. Dah balance ke ni? Dah balance ke 12 dengan 6 ni?
Belum.
Okay, belum balance lagi. So berapa yang tak cukup? 6. Arah mana? Kanan. Arah kanan. So arah kanan letak dekat A, B. Arah kanan letak dekat A, B. Okay, A, B. Yang ini ya. Yang ini. Arrow yang saya highlight tu belong to A. Arrow yang satu lagi ni, yang ni, hijau ni belong to B. Bila nak check, kena check dengan arrow yang color biru. Okay, so 6 dengan 6, 12. So value ni 6. 6. Okay? So continue. Continue. So dekat B kena balance juga dekat B. So dekat B pun kena balance. So tengok B. Dekat B tu apa yang ada? Ada negatif 6. Dekat B, kalau tak boleh nampak buat macam ni. So ini B. Sekarang ada 6. Right direction. So kena balance dengan left. And tengok juga Y value. Ada tak vertical force dekat B? Vertical force dekat B. Kalau ada 1 lawan dia 1. Kalau 1 lawan dia 1. Kalau 2 lawan dia 2. Kalau 2 lawan sini pun 2. Okey. Kalau sini 3 lawan dia 3. Okay, now tengok dekat B tu. Okay. 6 dengan 6. Okay, yang warna hijau ni. Balance. 6 dengan 6. Okay, why? BE. BE, what is the value? BE. Sini B kan? Okay, dekat B ni, what is the value? Sebab we have to check Y direction, we have to check X direction. X kita dah check, 6 dengan 6. Okay, Y. 1 dengan 1, 2 dengan 2, 3 dengan 3, 4 dengan 4, 5 dengan 5, kosong dengan?
Kosong.
Kosong dengan kosong. Kosong dengan kosong. So this is 0. 0. Okay. Kalau ada value sini. For example sini ada 10. So dia lawan dia 10. Opposite. Okay. It is 0. Okay. Okay. Settle dah. AE dah settle. Member force. AB dah settle. Member force. BC dah settle. Member force. Okay. Now. Between C, D and E. Mana nak pilih? Mana nak pilih?
C.
Mana nak pilih? Okey, C pun boleh. C pun boleh.
C.
Pun boleh. D pun boleh. Okey, sebab sekarang ni C dah ada satu unknown lah because kita dah ada 6 tu. Okey, so kita let's say kita pilih D dulu. Tengok D dulu. Okey, dekat D. 12 mesti balance back with 12. 1 negative, 1 positive. Okey? 12. So CD equal to? CD equal to? CD equal to?
6.
Is it 6? Tengok
Zero.
pada D. Kita sedang buat D ya. Kita sedang buat D. From D, it is 0. Okey, jangan tengok 6 ni. Sebab 6 ni kat sini belum resolve lagi. Okey. Lepas you dah determine CD from D. Yang ni dah confirm kata dia 0. Barulah boleh kita dapat another one. Okay, from C. Okay, now kita buat C. Okay, dekat C, so we have 6. We have 6. Yang ni. Allah. Okay, we have this. Dekat lagi. Okay. Sudah balance ke belum balance lagi? We have negative 6. We have negative 6. Must be balanced with positive 6. Where is positive 6? Where is positive 6? Sini. Complete the vector. Okay. It is again 6. 6 and 6. Because it is 3 and 3. 6 and 6. Okay. So, kita completekan. Ini simple than pagi tadi. Trust yang ni. Okay, pagi tadi lagi complicated. Okay, this one. 6, 6. So, this is 8.49. Okay, now dah complete. Okay, now dah complete. Okay, so member force. Dalam ni ada member force. How many? 8. 8 member force. Okay, 7 after we remove redundant. Okay, it is. Okay, member force dalam ni. AB is positive 6. AB. BC is positive 6. CD is 0. DE is positive 12. AE. AE is positive 8.49. BE is 0. And CE is negative 8.49. Okay, so yang color pink tu semua member force and not. Member force and not. So yang ni. So yang ni. Yang ni apa? This is and not. And not. Okay. Member forces in primary truss. Member forces in primary truss. Sebab tu tadi saya kata draw the bigger truss. Okay, jangan buat kecil sangat, nanti tak muat nak tulis. Okay. Due to, okay, yang ni senang. Yang ni senang dan sama setiap kali redundant is member force. Sama setiap kali the redundant is member force. Number 1, okay, catat Number 1, because member force is internal force, not external force. Okay, saya type kat sini. Okay, ni analysis of redundant truss. Redundant truss. Okay. So where FBD FBD redundant truss where member force is the redundant. Okay. Okay, characteristic number 1. Characteristic number 1. Because in the redundant structure, we will calculate reaction due to a unit value. In redundant structure, we will calculate reaction due to a unit value. When a unit value is come from when redundant is come from. Saya tulis saya. Okay, we will calculate reaction. We will calculate reactions in redundant truss due to a unit value of redundant. Okay, itu understanding number 1. Okay, number 2. Number 2, when reaction is the redundant. Reaction is the redundant. Tadi saya ada sebut reaction we get value of reaction which is come from external loading. Okay, when reaction is redundant, we will have reaction at the support. Reaction at the support. Okay, what happened now is member force is the redundant and member force is redundant. member force is redundant. And member force is internal force. Internal force. Reaction, we get the value of reaction. We get the value of reaction when we have external force. External force. Kalau redundant to reaction, kita apply a unit value of Cx, a unit value of By, a unit value of Ma. Semua tu it is assumed as external force. External force. So when there is external force, there is a reaction. Now, it is member force as redundant and member force is internal force. There is no external force here. So what happen is, kalau you nak try calculate pun boleh, you will get this is equal to 0, this is equal to 0, this is equal to 0. Because we get reaction value whenever the structure is subjected to external loading. Okay, now there is no external loading. Now, okay, another characteristic. When there is no external loading, there is no external loading, there is no reaction. Okay, no reaction. No reaction because there is no external loading. So what should we do when we have redundant truss and member force is the redundant? Okay, so due to this, automatically we will get this one as 0, this one as 0. Okay, so this is step number 1. Step number 1, we identify zero force member. We identify 0 force member. So we get 0 for sini kan A, B, C, D, E. Okay, we get 0 because 0 yang tadi ni, yang tadi kita balance dengan Y tu, yang ni tadi, kan dia lawan ni. Sebab ini arrow ke atas, ni arrow ke bawah. So 0 lawan dia 0. So 0 lah. Okay, so sini dapat 0. So yang ni become 0. Okay, so yang ni also 0. This one also 0. So when we have truss, okay, for redundant truss, when member force is the redundant, step number 1, we have to identify. Step number 1, we have to identify 0 member force. Okay. Okay, this is the step. So we have to identify 0 member forces. Okay, next is okay. Next is okay, ni tak complete lagi because in this structure we have to apply a unit. This is kena tengok definition redundant. Sorry, lupa letak tadi. Okay, we have redundant truss that is subjected to a unit value of redundant. Subjected to a unit value of redundant. It is positive. Positif dia macam ni. Tapi kita tak draw satu line macam tu, kita buat macam ni. Okay, kita buat line macam ni. Representing yang tadi. Okay, yang ni arrow positif. Arrow positif. So this is 1. This is also 1. Okay, that is 1 times FBD. 1 times FBD and FBD is member force. Bila kita calculate reaction, memang kita tak akan dapat reaction value because FBD is member force. Okay, now we will determine member forces. Okay, member forces dalam petak tu. We will determine member forces dalam petak tu without reaction value. Okay, the first step is kita kena identify zero member forces. Next step is kita kena make sure kat sini ada a unit value first, a unit value of redundant. It is positive 1 times FBD because original it is FBD dekat sini. Okay, now next step. Okay, next step is we resolve in X and Y. Okay, a unit value of redundant. A unit value of redundant. A unit value of redundant. Okay, we resolve in X and Y direction. Guna konsep vektor kan? Okay, use vector. Okay. Ini bukan untuk hafal. Ini kalau you faham, you akan buat all these things. Okay, use vector. So, kat sini kita nak fokus yang segi 4 tu je, petak tu. Okay, now kita nak resolve. Okay, in X and Y. Bila dia incline force, incline member, kita memang kena resolve in X and Y. Okay, resolve in X and Y. X and Y. X and Y. Resolve. Okay, lepas dah resolve, kena buat balancing. Kena buat balancing. Setiap join ada one unknown. X pun one unknown, Y pun one unknown. Setiap join dekat B dengan D, cuba tengok dekat B dengan D, dia ada one unknown. Bukan one, two unknown yang balance. Dia balance. Dia takkan ada 3, dia ada 2. So dia kena balance lah. So kita kena letak arrow, play with the arrow untuk balancekan arrow yang lagi satu. Okay, kita ada arrow to the, kalau pada B, arrow to the right, lawan the arrow to the left. Okay, kita balance dengan dua ni. Balance. Sama juga yang arrow ke atas, balance dengan arrow ke bawah. Okay, benda ni bukan flexibility method tau. Benda ni determinate truss. Member forces analysis using determinate truss. Bukan flexibility method. Okay, jangan sebab ni you tak suka flexibility method because this is determinate truss. Okay, so yang ni dah ada satu ke bawah, completekan. Jadi satu ke atas. Okay, so dah settle dekat B. Sama juga we do the same dekat D. Dekat D, dia ada satu ke bawah. Satu ke atas. Balance. Okay. One is down, one is up, one is left, one is right. Balance. That's why tadi saya kata 1 lawan 1 tu. Dia 1 lawan 1. Bukan satu unknown. 1 lawan 1. 2 unknown but 1 lawan 1. Okay. Balance. So bila sampai dekat E, kita ada satu arrow. Lawan dengan satu lagi arrow. Opposite. Okay. Dan sama juga dekat Y, ada satu arrow naik atas, satu arrow ke bawah. Okay. So dia jadi 1 lawan 1, 1 lawan 1. Okay. So yang ni completekan. Jadi hypotenuse. Then completekan. Okay. CD, member force mesti ada arrow like this. It is not member force kalau ada satu je arrow. Dia mesti ada dua opposite arrow. Two opposite arrow. Okay. Macam ni. So dekat C, bila satu di bawah, satu ke bawah, downward, balancing. Satu naik atas. So barulah yang ni balance. 1 lawan 1. Okey, 1 lawan 1. 1 lawan 1. Reaction tak adalah, reaction 0. Okey, reaction 0 which is tak perlu pun letak. Understood. Okey, yang ni semua tak perlulah. Understood. Okey, so dah dapat vektor ni, complete kan? So 1 lawan 1. So dapatlah macam ni. Okey. So memang kalau truss member force is the redundant, you kena hafal step ni. Okey, kena hafal step ni balancing. Balancing. Okey, balancing. Lepas dah balance, use trigonometry to find x value and y value. Lepas dah buat balancing, okey, nombor 6 tu, nombor 7. Okey. Balance, buat balancing lah. Balancing. Okey, balancing. Okey. In X and Y. Okey. Sini 1 lawan 1. 1 lawan 1. Balancing. Okey, 8. Now, we use trigonometry. Use trigonometry. Ni matematik. Trigonometry. Use trigonometry. Calculate X and Y value. X and Y value. Use trigonometry. Calculate X and Y value. Okay. Use trigonometry. Calculate X and Y value. Use trigonometry. It means that kalau tadi trigonometry ni kan 3. Okay. Trigonometry for this is 3 and 3. Okay. 3 and 3. And hypotenuse ni is 4.24. Please check. 4.24. The hypotenuse. Okay. The hypotenuse. Okay. Now, we have a unit value which is hypotenuse. 1 ni. Yang ni. Yang ni is a unit value 1 which is hypotenuse. So, we have to do interpolation lah. So, kat sini saya tambah trigonometry and interpolation. Use trigonometry and interpolation. Ya. Trigonometry and interpolation. Okay, use trigonometry and interpolation. Use trigonometry and interpolation. So, we should have 2. So, 1 is the hypotenuse. So, what is value of X? What is value of Y? Siapa boleh calculate? If we have 2 triangular, okay, we have 2 triangular, 3 dengan 3. And then hypotenuse is 4.24. Please recheck. Okay, we have another triangular. We have another triangular. 1 is the hypotenuse. 1 is the hypotenuse. So, what is X value? X and Y. Berapa nilai ni? X and Y. Same value. So, ini jangan kata tak tahu kan. This is mathematics. What is X? What is Y? When we have 2 triangular, we compare like this. Okay, we use interpolation to identify X and Y. Berapa nilai X dan juga Y?
X 0.71.
Okay, it is 0.7071. Betul? 0.7071. Kan? Okay. So, that is the value that you need to put into the diagram, the redundant frame. So, the X value is equal to 0.7071 X value and Y value also 0.7071. 7071. And CE again 1. CE 1. Okay. Like this, we determine member force. Okay. Ramai yang tak confident, you nak buat guna method of join, doesn't matter. Tapi lagi lambat. Because yang ni, kalau nanti you dah faham, memang tak ada formula nak bagi tahu, okay, guna formula ni, you akan dapat member force. Tak ada formula tu. Memang you kena buat latihan untuk faham macam mana kita buat truss ni. Okay. Kita try sekali lagi. Cepat sikit. Try sekali lagi cepat sikit. We have truss ni. Macam ni member force. Ini 12. So, sini 12. Okay. And then 6 sini. 6 sini. Kan? Macam tu ke tadi? Kita balik. Okay. Kalau salah reaction, you takkan dapat. So, sini 6. Sini 6. Positif. Okay. You memang kena practice a lot. Practice a lot. So, by looking at this truss. Okay. Yang ni 12. Yang ni kosong. Okay. So, yang ni bawah atas 6 dekat A. So, 3, 3. So, 6, 6. Trigonometry. So, yang ni 6. Yang ni 6. 6 dengan 12. So, ada remaining. Ada lagi satu 6 kat sini. So, dapat yang ni 6. Dapat balance dengan 6 belah sini. Okay. So, dapat sini 6. Balance dengan 6 dekat sini. 6. And 6. So, 6 yang from this. Balance dengan 6 yang kat bawah ni. Okay. Opposite. 6 dengan 6. Okay. Yang ni 0. Sebab dekat sini, dekat B ni, for Y value tak ada value. So, it is equal to 0. Okay, yang ni. Okay, 6, 6 sebab 3, 3. Okay, so yang ni ke bawah dengan atas. Nampak tak? Ni bawah, atas, balance, kiri, kanan. Sekejap, terbaliklah ni. Betul ke? Okay, dah tulis salah dah. 6 bawah atas. 6 bawah atas. 6 bawah atas. Ni 12, 12. Betul lah. Betul. Okay. So, yang ni primary truss. Redundant truss. Redundant truss. Macam ni tadi. Redundant tu. Okay. Redundant truss. Member force. A unit value. Sini satu. Sini satu. Okay. Bila redundant is member force. Automatic reaction 0. So, yang ni akan jadi 0. Okay. Resolve dulu. Resolve. And then balance. Silap. Kanan, kiri. Bawah, atas. Kiri, kanan. Okey, bawah, atas, bawah. Ada satu member terlupa. Ada member kat sini kan. Okey, bawah, atas. Okey, atas, bawah. Kiri, kanan. Okey, bawah, atas. Kiri, kanan, kiri. Okey, yang ni je. So, guna trigonometri untuk identify X and Y value. X and Y value. So, we have two triangular. Macam ni. Okay, one tu is hypotenuse. One is hypotenuse. So, tadi kan 3, kan? 3, hypotenuse is 4.24. 4.24. So, kita dapat X and Y. X and Y. Macam mana calculate dia? Macam mana calculate X and Y? X is 3 over 4.24. Okay, Y also 3 over 4.24. Okay, so that is why we get 0.707. Okay, kalau you faham, you boleh buat. Ya, ya.
Untuk number process ni tak perlu tunjuk calculation ke?
Tak perlu, tak perlu. Tak perlu. Because you kena ingat yang waktu saya selalu ulang learning outcome. Learning outcome for flexibility method. Learning outcome for flexibility method. Can you choose redundant? How you calculate redundant? How you choose redundant? Okay, how you choose redundant? So how you calculate the redundant using compatibility equation. Compatibility equation using displacement in both system. And ni bukan learning outcome for flexibility method. Learning outcome for flexibility method yang tadi redundant, compatibility equation, reaction in total reaction, the last step, member forces in actual system. Member forces yang kita buat dalam step ni is to fulfill formula. So you don't need to show macam mana you dapat member force ni. That's why kalau you faham member forces ni, you just fill in the value into this. Fill in je. Okay, dapat diagram satu primary, satu redundant like this. So sini letak 0.707, sini 0.707, sini 0.707, sini 0.707, and all these member forces kita kena transfer ke table. Selagi tak dapat table, tak buat table, you takkan dapat the displacement. Okay? Sama juga macam beam analysis, frame analysis. Member forces tak perlu tunjuk pun. Member forces, step nak calculate, nak write member forces, cutting section semua tu, tak wajib untuk you tunjuk. Yang kita buat tu, because that is the process. Tapi kalau you are able to write the moment equation, tengok je beam tu yang dah ada reaction. Daripada situ you boleh write equation directly, tak perlu tunjuk moment equation. Sama juga dengan yang ni. And tu dia adalah part of analysis, part of step. Yang kita nak adalah displacement tu. Okay, displacement tu. So kita nak sekarang ni nak member forces yang ada dalam table. Okay, maksudnya member forces yang you dah calculate tadi tu kena masukkan dalam table with the right label. Negative is negative, positive is positive. Kalau you boleh masukkan value tu ke dalam table tu, that is the step, that is the procedure. Okay, bukan procedure macam mana you kira member forces guna method of join, bukan. Macam mana you nak transfer N0 and N1 dalam table. Okay, that is the procedure. Okay, so member we have member table ni, kalau table for beam and frame, kita buat table tu because kita nak summarizekan all the moment equation. Okay, table in truss because we want to find total ni. So table kita buat because of this. Because without table, we cannot get the summation N1 N0 L and N1 square L. We want to have table because we want to find these two values. Okay? EA constant tak apa. Put outside. Okay? We want N1 N0 L total. In total. We want N1 square L in total. In total. So from that, kita create table. So member L in meter, N0 N1, N0 N1. Because nanti kita nak kali kan. N0 N1. So we have one column for N0. Yang ni. N0, 1 column for N1, okay, and 1 column for total, means N0, N1, L. N0 bukan total lagi. Kita combine N0, N1, L sebab kita nak nanti N0, N1, L dengan N1 square L. So kita nak N0, N1, N0, N1, N0, N1 kali L. Kali L. Kali L. Label ni, and actually label yang kita pakai dalam compatibility equation tu akan guide kita what is the next step, Okay, so this is delta, this is N, not N1L, and satu lagi is N1 square L. N1 square L is N1, N1L. Okay, tulis N1 square L pun boleh, tulis N1, N1L pun boleh. Okay. Okay, tujuan kita nak cari summation 2 ni. And summation ni kita hanya akan dapat from table. Kenapa kita ada column for L? Kenapa ada column for N0? Kenapa ada column for N1? Because of these two. Okay, we have 8 members. We have identified at the early stages 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9. 9 for summation. Okay, 9. Okay, list all the members in actual trust. List all the members. Tadi masa kita calculate DOI, it is 8. Member is equivalent to 8. So, listkan all 8 member dalam ni. Okay, we start with AB. And then BC. And then CD. CD. List all the member. AB, BC, CD. AB, BC, CD, AB, BC, CD, DE, AE, DE, DE, AE, DE, AE, 5, AE, BE, CE, BE, CE, and redundant is BD. So BD. Because we have to list all the member force, including redundant in actual system. Okay, so this is all the members. Length for AB is 3. Length for BC is 3. Length for CD is 3. Length for DE also 3. DE also 3. Length for AE is 4.24. Is 4.24 the hypotenuse. BE also 4.24. CE. Mana CE? CE Sorry, BE3 BE3. BE punya vertical 3. So yang ni 4.24. 4.24. Okay. So now kita ambil nilai daripada trust tu lah. Okay. And not for primary trust. Primary trust. Okay, yang color pink tadi. Okay. 6 positif, 6 positif, 6 positif, 660, 660, 12 positif, 660, 12. So it is 660, 660, 12 is also positive. 12 is also positive. And then this one is positive 8.49. Positive 8.49. 8.49. Okay, BE is 0. BE is 0. Okay, BE is 0. CE atas. Okay, CE is negative 8.49. Negative 8.49, negative 8.49. And BD is 0 because there is no BD in primary truss. Okay, so now we transfer N1 value. Okay, 0. 0, negative, it is 0. Negative 0.7071. Okay, CD also negative 0.7071. DE also negative 0.7071. AE is 0. BE is negative 0.7071. CE and BD kan? 1 and 1. Okay? So this is N1. This is N1. Okay, now kena kira lah ni. 3 times 6 times 0. 0. Okay? 0 times 0 times 3. Also 0. Okay. 3 times 6 times 0.7071. 3 times 6 times 0.7071. We get negative. We get negative. Berapa?
Negative 12.772.
72. Okay. Okay. Okay, now 0.7071 square times 3. It is positive. 0.7071 times 3. Times 3. Berapa?
1.5.
1.5. Okay. 1.5. Okay. So yang ni 0. Yang ni also 1.5. Okay. Okay. Yang ni pula Okay. 3 times 12 times 0.7071. Negative. 3 times 12 times 0.7071.
Negative 25.46.
46. Okay. And we get 1.5 again.
35.
20 or 30? 30 ke 20?
20.
20.
25.
25.46. Okay. N1 square L. N1 square L sama macam tadi. 1.5. Okay. Next. AE. Yang ni 0. Yang ni pun 0. Okay. And BE. BE 0 and 1.5.
1.5.
Okay. Yang ni pula. 4.24 times negative 8.49.
35. Negative 35.
35.
0.99.
36.
998.
36.
Okay, 36. Okay, 36. And then 1 times 4.24. 4.24 lah kan?
4.24.
Okay. Last one. Yang ni 0.
4.24.
4.24. Okay, total. Dua-dua ni kena totalkan. Okay, dua-dua kena total. Okay, totalkan negative 12.72 minus 25.46 minus 36. So what is the total? Berapa?
Negative 74.18.
Okay. And total N1 square L 1.5, 1.5, 1.5 ada 4 kali 1.5. Berapa tu? 6. 6 tambah 8.48 ni berapa?
14.48.
Okay, 48. Okay, now. So this is the summation lah. This is summation. Okay. So this summation we substitute into the compatibility equation. So we will have compatibility equation. Okay, compatibility equation. Compatibility equation. Also known as flexibility coefficient, as flexibility equation, Okay, so it is the formula, this one. Okay, this is the compatibility equation. So sampai this stage, I believe you dah boleh continue lah. Okay, so delta 1 node ni, delta 1 node is per dengan EA, per dengan EA, ni kat sini, per dengan EA, so this is EA, so sini negative 74.18, okay, and yang ni, over EA, it is 14.48. It is equal to 0. Okay. So then we solve. So when we solve, what we get? We get FBD. FBD equal to 74.18. We divide by 14.48. So what is the answer?
5.12.
5.13.
Yes.
Sini.
Oh, 5.13.
Okay, 5.13. Okay. So dah dapat ni. So reaction, three remaining reaction because member force is the redundant. So reaction tu tak ada changes. Reaction dia akan sama dengan primary. Kan sebab reaction dia 0 kan. So normally kalau redundant tu, if redundant is member force, soalan akan minta you calculate member forces. Kau tengok soalan ni kan. Member BE. Sebenarnya kita nak calculate semualah member forces. Sebab kalau member force is the redundant, normally dia tak minta reaction. Sebab reaction akan sama macam reaction in primary frame because kita tak ada nilai AY, AX dengan CY in redundant frame, redundant truss. Betul tak? Kita kan guna principle of superposition. General equation, actual truss equal to primary truss plus redundant truss. In primary truss, we have reaction. In redundant truss, we also have reaction. But this case, reaction in redundant truss is 0. All 0. So, reaction kalau kita kira pun kita akan dapat balik sama nilai dengan primary truss. Sebab 0 times redundant kan. Okay, so normally kalau redundant is member force, soalan akan minta you calculate member forces in actual truss. Okay, we continue. Continue to calculate. member forces in actual trust. Inilah soalannya kan. Inilah diagram yang diberi dalam soalan. Continue to calculate member forces in actual trust. And to calculate member forces in actual trust, okay, we don't need to apply equilibrium equation and repeat again guna method of joint untuk calculate. And we also don't need to repeat balik method of easy method tadi yang kita buat untuk calculate member forces. No need, because by applying principle of superposition, okay, we have general equation. Saya completekan sikit je lagi. Okay, by applying principle of superposition, it is they start with general equation kan. General equation. Yang ni tak payah tulis. Just remember. Okay, tapi untuk practice doesn't matter, boleh tulis. General equation. Apa dia general equation? Actual trust. Okay. We want to calculate member forces in actual trust equal to primary trust. Plus redundant trust. Redundant trust. Okay, this is from the principle of superposition. Okay, so we want to have member forces in actual trust and the symbol is N. Member forces in actual trust, the symbol is N. So N lah kat sini. So sini N. Okay, dekat sini N ya. It is N. N equal to member forces in primary trust. What is the symbol we use? Member forces in primary trust?
N naught.
Okay, it is N naught. Okay, plus with
N1.
Yes, N1. Alone? Is it alone? N1
Time
only?
FBD.
Yes, we have to times with redundant. In redundant structure, everything must times back with redundant value. FBD. FBD. Okay, so it is equal to it is 5.13 kan? 5.13. So we put the value lah 5.13 and 1. Yang ni padam lah. Yang ni padam. Okay. So nampak tak? N naught plus 5.13 N1. Okay. Is actually the formula to calculate member forces in actual trust. Okay. So kat mana nak cari, nak letak ni, boleh letak balik dekat table, tambah satu lagi kolom. Atau boleh buat satu lagi table, tapi kalau tak nak, just tambah another column dekat sini. Okay, insert right. Insert right. Okay, kat sini. Because dalam table ni, we have N0, we have N1. Okay, we have N0 and we have N1. So, we take this. Okay. So, this is N. So, this is N. So, boleh tak dapat N? Now, when we have the formula.
Boleh.
Okay, this is N equal to. Okay, please calculate. Kita habiskan. Alang-alang habiskan lagi sikit ni, table ni. Okay, what is the value for AB? What is the value for AB?
6.
Okay, it is 6. Ini 6. Okay, next value. Next value. 6. Okay, next value. Okay, what is the next value?
$2.37.
2.37. Is it right?
Yes.
Okay, next value. Negative. Negative.
3.627. 627.
3. 3 ke?
6, 6,
6.
27.
Okay. Okay. Next value. Next value.
8.37.
8.37. Negative or positive? Positive eh? 8.37.
Positive.
Positive. Okay. So next is 8.49. 8.49. Okay, next is negative 6.27 ke?
Negative 3.63.
3 point?
6.
Negatif 3.63.
3.63. 3.63. Bukan sama je ke dengan atas tadi?
Atas salah.
Okay, 3.63 lah ni.
Yes.
3.63. Okay. Okay, next. 3.63. Okay, next.
Negative 0.36.
Negative
Negative 3.36.
3. 3. Is it 3?
3.36.
3.36. Yang ni ke? 3 point. Okay, 3.36. And another one?
5.13.
5.13. Okay, make sure you calculate the right answer based on the formula, okay, that we get from principle of superposition. Okay, if we use equilibrium equation, means that we have to repeat to calculate member forces using method of joint or easy method. But we actually have the easiest way, and the easiest way is by using principle of superposition. Sebab tu tadi dalam soalan kuis saya tanya. Okay, reaction, the final step in beam and frame is reaction. Lepas reaction tu boleh continue lah to draw bending moment shear force diagram. But when we analyze truss, the final step is member forces. Okay, in truss analysis, we calculate unknown reaction and member forces. Unknown reaction and member forces. Tapi kat sini saya tak tunjuk member forces because you will get the same. Example pagi tadi, sebab reaction due to redundant due to reaction. Redundant tu come from reaction. Okay, yang tu you akan dapat new reaction. New reaction in actual system. So kiralah reaction and member forces. Yang ni because of redundant come from member forces, reaction you akan dapat balik the same like primary system. Okay, and member forces memang you akan dapat all new lah. Okay, new value. Okay, so read the question carefully. So you have to understand all the step lah, all the step. Okay, take note all important things yang I always repeat, and I have also list all the important things here. Okay, semua step saya dah tulis. Okay, if you don't understand, please ask. Okay, so this is basically analysis of truss using indeterminate truss using flexibility method. We have externally indeterminate truss. I have discussed in morning class, and this is this is internally indeterminate truss. External indeterminate redundant come from reaction. Internally indeterminate truss redundant come from member force. This is for one redundant because there is a question combination of externally and internally means there are two redundant. One come from reaction, one come from redundant. So there are the three trusses. Okay, for you to determine N0, N1, N2. Okay, so try to understand one first. Okay, normally dalam exam tak adalah bagi sampai 3 redundant untuk truss because we know that macam it is very hard to especially determining the member forces. And anyway, yang ni memang nampak susah mungkin sebab you tak pernah buat sebelum ni using easy method. Kalau yang dah pernah buat tu boleh guide kawan-kawan jugalah. For first time memang nampak susah, tapi kalau you do it regularly. So benda-benda macam ni you kena jadikan dia regular activity. So that bila dia regular activity, you will find that benda ni tak susah mana pun. Kalau you faham easy method yang saya buat tadi tu, actually member forces in primary truss, member forces in redundant truss, you can finish within 10 minutes. Not more than 10 minutes. Kalau you understand about easy method, dalam easy method tu ada trigonometry, ada vector, ada trigonometry. And then kalau yang tadi ni redundant truss, kita kena balance. Okay, play with the arrow, kena balance balik. Lepas tu kita calculate using two triangular interpolation. So repeat the same process. And truss apa pun bentuk dia, kalau redundant come from member force, you akan repeat the same thing again and again. Macam ni juga setiap kali, except dia punya yang ni lah, trigo dia ni tak mestilah 3 dengan 3. Okay, dia punya trigonometry tu berubah. Trigonometry ni kan, trigonometry ni. So you akan buat interpolation based on trigonometry itulah. Okay, the rest are all same. Okay, this is truss analysis. So kita dah cover truss analysis, externally indeterminate and internally indeterminate. Okay, I will set another session next week. Next week should be ada kelas kan? Tapi you all dah start balik. So kita akan buat insyaAllah minggu depan dah week 5 ya? Kan this is week 5. Week 6. Means that week 5 ni dah habis lah kalau ikut dalam lesson plan. 5 week for flexibility method. So actually I have cover 95%. Okay, dah 95%. Saya dah explain pasal support settlement juga. And dalam trust ada effect which is come from ada effect yang nama dia fabrication error and temperature changes. Yang tu saya akan cover dalam satu lagi slot. Macam mana kita nak include effect tu dalam analisis ni. Dia basically sama, cuma dekat mana kita nak include. Ada new formula yang kita kena include. Lepas tu another session for composite structure. Just a short one yang tu. Okay, so basically yang inilah dia flexibility method. Okay, flexibility method. Where I believe all of you understand what is flexibility method. The process you understand. Tapi selalu yang perangkap student adalah basic understanding. Okay, basic understanding in analyzing determinate beam, determinate frame and determinate truss. Kalau basic understanding in writing moment equation, in calculating member forces, yang tu memang you dah master. Yang ni macam kalau keluar member forces ni at any time you dah boleh buat. Okay, you should not face any problem relating flexibility method question. Okay, so take time to practice basic. Okay, basic a lot. Okay, and itu je lah flexibility method. Kalau you do lot of exercise, jangan sekali-kali tinggalkan flexibility method bila you masuk topik lain. Sebab bila you tinggalkan langsung, nanti bila you open back for final exam, you akan tengok ni macam first time. Macam tak pernah belajar flexibility method. Okay, bila you tengok balik for first time, rasa macam first time tengok balik, macam tak pernah belajar flexibility method, you kena guna akal untuk remember everything. Which you cannot. Tak boleh remember. Okay, kalau you remain doing regular activity, regular exercise, so you akan dah familiar dengan benda tu, you tak lupa, insyaAllah you boleh buat final exam. Okay, so that's all for this week session. So kita jumpa balik insyaAllah online session next week. Okay, I'm so sorry because kelas Rabu, kelas Khamis saya tak boleh buat. Sebab I need time for preparation for International Construction Week. Saya as speaker and this is my second time. Okay, second time CIDB invite me lah. So kena get prepare for that one. Tak ada experience. Thank you. Tak ada experience sangat pun. This is my second try. Tapi first try dulu hybrid. Masa first try dekat hotel The Light, yang tu hybrid session. Hybrid session where dekat depan ada penonton lebih kurang 100 orang dan ada online session juga. Yang join lebih kurang 2,000 lah masa tu. Yang ni online session. So dekat Berjaya Times Square tu belakang ada green screen. So online session. So saya nervous juga. And this time maybe because this is International Construction Week, so I have to deliver in English about construction 4.0. So hopefully everything goes well lah. Okay, so kita jumpa balik insyaAllah next week. InsyaAllah next week for online session. So do regular exercise. So all exercises that you do, please put into class notebook. Not only latihan yang saya minta you submit. Okay, kalau you ada buat extra pun you letak di dalam class notebook tu. Okay, so thank you very much. Thank you for joining the class point activity. Okay tadi. So we will meet again insyaAllah next week. Okay, jumpa lagi. Assalamualaikum. Ya?
Boleh ke nak minta answer untuk yang 3 hari bulan 11 hari tu yang dah submit?
3 hari bulan 11. Saya check ada tak, kalau sempat saya buat lah. Okay, sebenarnya you boleh download satu software tau. saya lupa apa nama software tu, tapi dia open source software yang mana you boleh, dia tak macam Esteem yang complicated sikit lah. Dia macam very simple. You boleh draw beam, frame, truss ni dalam tu. Lepas tu apa dia? Ada 2-3 open source juga software yang every time you buat, you boleh recheck answer dia tu. Okay, yang tu you boleh try juga. Yang jawapan tadi tu saya check dulu ada tak jawapan. Okay, tapi it's good kalau you buat and share. Okay, you buat and share your answer in Teams conversation. I'm waiting for you to respond in Teams because I will register this course as blended learning course, and for blended learning course kena ada evidence. So saya lagi suka kalau you respond saya dalam Teams. Okay, so that benda tu jadi evidence lah. Jadi strong evidence for blended learning. Okay. So anyway, saya akan letak dua-dua lah. Tapi kalau yang soalan-soalan you nak tanya, you boleh tanya direct dekat Teams. Okay. So kawan-kawan boleh buat juga and share the answer and the rest boleh check. Okay.
Okay, thank you Doktor.
Okay. So sesi ni saya akan upload lepas ni. Lepas ni in YouTube, so tengok baliklah kalau untuk repeat lah untuk more understand. Okay, thank you.
Doktor.
Ya.
Thank you Doktor.
Attendant
Good
kami
luck.
dalam
Attendance tadi saya set dekat you future, you tick tak?
tak sempat lah.
Tak sempat doktor.
Tak sempat doktor.
Kami fokus.
Fokus sangat tadi.
Oh, bagus. Okay, tak apa. Nanti saya akan double confirm dengan attendance dalam Teams. Okay, saya akan tick manually lah yang tu. Okay?
Okay, thank you doktor.
Okay.
Thank you doktor.
Okay.
Thank you doktor. Bye bye.
Thank you, doktor.
Bye. Assalamualaikum.
Thank you doktor.
Thank you doktor. All the best.
Okay, thank
Terima
you.
kasih doktor. Selamat malam.
Malam.
Doktor. Selamat malam doktor. Thank you doktor.
Okay, thank you.